Or, have you ever stood on a platform, watching a massive train roar past, and wondered, what's actually going on inside that powerful machine at the front? The locomotive, the engine, the big kahuna that pulls everything along. It looks like a solid block of metal from the outside, but what secrets does it hold within? Well, today, we're climbing aboard to find out. We're going to peel back the layers and explore the fascinating world inside a modern train locomotive. So, grab your virtual ticket. Because this is a journey you won't want to miss. First things first, let's step into the cab. This is the nerve center, the cockpit of the train. It's where the engineer and conductor spend their entire journey. Forget what you've seen in old movies with a guy shoveling coal. Modern cabs are high-tech control rooms. You're immediately surrounded by screens, dials, levers, and buttons. It looks complicated, and honestly, it is. Front of the engineer's comfortable, often air-cushioned seat is the control stand. This is where the magic happens. The most important controls are the throttle, the brake, and the reverser. The throttle is like the gas pedal in your car. It controls the power going to the traction motors and determines how fast the train accelerates. It's not a simple pedal, though. It's usually a large lever with several notches. Each notch represents a specific power level. Pulling it back, notch by notch, increases the power. The engineer has to be incredibly skilled to apply power smoothly, especially with a train that could be over a mile long and weigh thousands of tons. Too much power too quickly, and you could break the train apart. Next to the throttle, you'll find the brake levers. There are typically two, the automatic brake and the independent brake. The independent brake applies the brakes only on the locomotive itself. It's used for precise movements when connecting to cars or for slowing down just the engine. The automatic brake, on the other hand, applies the brakes throughout the entire train, all the way to the last car. This is done using a complex air pressure system that runs the length of the train. It's a fail-safe system. If the airline brakes, the brakes automatically apply. Safety first. Then there's the reverser. It's a simple lever, often removable as a key, that determines the direction of travel, forward, neutral, or reverse. You can't just throw it into reverse while moving forward, though. The train has to be completely stopped. Look around the cab, and you'll see a dizzying array of screens. These are the modern equivalent of all the old analog gauges. They display critical information like speed, air pressure in the brake lines, amperage of the traction motors, and diagnostic data from the engine. There's also a display for the distributed power system, which allows the engineer to control other locomotives placed in the middle or at the end of the train. And of course, there's the horn and the bell. The horn is incredibly loud, for obvious safety reasons. And engineers use specific patterns of blasts to communicate signals, like when they're approaching a crossing. But the cab is just the front office. What about the rest of this metal beast? Behind the cab's back wall is where the real powerhouse lives. Let's step through the door and into the engine room. Be warned, it's loud in here. The first thing that dominates the space is the prime mover. This isn't just an engine. It's a colossal diesel engine. We're talking 16 or even 20 cylinders, generating anywhere from 4,000 to over 6,000 horsepower. This engine is massive, often taking up more than half the length of the locomotive's body. It's the heart of the locomotive. But here's a common misconception. This diesel engine doesn't directly turn the wheels. So, what does it do? It turns a giant alternator, or in some older models, a generator. Think of the locomotive as its own mobile power plant. The diesel engine's sole purpose is to generate a massive amount of electricity. This is why modern freight trains are actually diesel-electric hybrids. The high-voltage electricity produced by the alternator is what powers the entire system. From the alternator, the electricity goes to a rectifier. This is a crucial piece of equipment that converts the alternating current, or AC, from the alternator into direct current. or DC. This DC power is easier to control and is sent to the traction motors. What are traction motors? These are powerful electric motors mounted on the axles of the locomotive's wheels, a setup called a truck. Each axle typically has its own traction motor. So, a standard 6-axle locomotive will have 6 traction motors. These motors are what actually turn the wheels and move the train. An engineer in the cab is essentially controlling how much electricity is being fed to these motors. As you walk down the narrow corridor of the engine room, you'll see a complex web of pipes, wires, and machinery. You'll pass the air compressors. These are vital for the brake system, the horn, and other pneumatic controls. They keep the air reservoirs topped up, ensuring the brakes are always ready. Further down, you'll find the cooling system, that massive diesel engine generates an incredible amount of heat, and it needs to be cooled, just like your car's engine, but on a much grander scale. You'll see huge radiators and giant fans, often visible from the outside, on the roof of the locomotive. They work to dissipate the heat from the engine coolant and the oil. Another interesting component is the dynamic brake system. When a heavy train is going downhill, just using the air brakes can cause them to overheat and fail. That's where dynamic brakes come in. When activated, the system reverses the function of the traction motors. Instead of using electricity to turn the wheels, the momentum of the wheels turning the motors turns them into generators. This process creates a huge amount of electrical resistance, which slows the train down without ever touching the friction brakes. But what happens to all that electricity it generates? It's sent to huge grids of resistors, which look like giant toaster coils, located on the roof. These resistors get red hot as they convert the electrical energy into heat, which is then blown away by massive fans. It's a brilliant way to control speed and save wear and tear on the brake shoes. Don't forget the sand. Locomotives have sandboxes that hold, well, sand. If the wheels start to slip on the rails due to rain, leaves, or heavy loads, the engineer can press a button to spray sand directly onto the track in front of the wheels. This dramatically increases friction and helps the train get a grip. And finally, at the very back of the locomotive, you'll usually find more electronic control cabinets and sometimes even a toilet for the crew. It's a cramped but essential feature for long journeys across the country. From the high-tech command center of the cab to the thunderous power of the diesel engine, the electrical wizardry of the alternator and traction motors, and the clever engineering of the dynamic brakes, a train locomotive is so much more than just a big engine. It's a self-contained rolling power station, a masterpiece of engineering designed for one purpose: to move incredible amounts of weight across vast distances with power and precision. The next time you see a train, hope you'll have a new appreciation for the incredible complexity and power hidden just beneath its steel skin. Thanks for joining me on this tour. If you enjoyed this peek inside the world of trains, make sure to hit that like button and subscribe for more deep dives into the machines that move our world. See you on the next one.